Hi guys, and welcome back to the ACE Academy. In this video, we'll be looking at the proof for the area rule. Now guys, when it comes to working out the area of any triangle, we know that the formula is half base times perpendicular height. Now that perpendicular height part is very important, because when it comes to working with normal right angle triangles, we can find the perpendicular height. But in this case, we are working with a non-right angle triangle, which means this triangle has no right angle whatsoever. So how would we find the area for a triangle like this? Simply, this is how you would do it, just like how we proved the sine rule and we proved the cos rule. We will start off by dividing this large non-right angle triangle into two right angle triangles that are a bit smaller. And these two right angle triangles make up this entire huge non-right angle triangle. And I will label this point D. And just for this case, for this scenario, I'm going to label this vertical line H. And you will see why. Okay? Now, when it comes to proving the area rule, we're going to start off with the formula for area of a triangle. And that would be area is equal to half base. So let's look at what's the base in this triangle. The base of this triangle will be AC, because that's at the base. So we're going to start off with half AC. And let me just label the side quickly. I think I forgot to do that. So that side AC would actually be labeled as small b. The side BC would be labeled small a. The side AB would be labeled small c, because it is opposite the corner C, right? So looking at this formula again, going back to what we were doing previously, our base would be AC, and that is actually small b. So we're going to just label it small b. Now let's look at the height. Now the height in this case is an imaginary line that we had constructed. So we're going to have to find it in some way so that we can use it in this formula. Let's look at triangle ABD. That is this triangle over here. That is triangle ABD. If we are using corner A as a reference, right? If we are using corner A as a reference, this height over here, and let's say we want to use a value that we already have, so I'm going to use the hypotenuse of this triangle, which would be side C. I'm going to apply sine, because sine is opposite over hypotenuse. So sine A, because that is the angle that I'm working with, is equal to opposite, which is H, over hypotenuse, which is C. Now let me solve for H, because H is what I'm looking for. It's an imaginary line that I constructed. Using my basic manipulation skills, if I multiplied both sides of this equation by C, I would obtain the equation of C sine A is equal to H. So if I am going to use this part in my formula and I need H because H is my height, I can simply put in place of H C sine A, and it is proven. It's that simple, guys. This is probably the easiest of the three proofs that you need to know for trigonometry. All the best, good luck with the studies, and I will see you in the next one.